Hello, my name is Matthew Kaleko, and this is my presentation for the redesigned flashlight. A big question is, what do people really want in their flashlights? Well, I took it upon myself to figure this out. What you see here is a chart of customer needs that I found by interviewing real people and tracking what they had to say about their current flashlights and what they would like to see. I asked 9 different people the same 7 questions, and I got a ratio of the different issues that they have with their flashlights and what they would like to see improved. During the duration of these interviews, I observed their verbal answers as well as their physical body language to try to get the best accurate results. Out of the 7 questions I asked, these questions is what was brought up the most and what people thought the issue was with their flashlight. This shows what people would want to see changed. The majority I asked had issues with the grip comfortability, the size, the weight of their flashlight, the battery life, and the actions that the flashlight could perform. For example, scissors on their flashlight, or for example, maybe something to clean. So now let's go over our action plan. Our mission is to create a flashlight that is not only fitting to our customer needs, but goes beyond and makes this flashlight better than every single one of our competitors in all categories. To get the results that we needed to be able to make our flashlight better than the rest is we used benchmarking. What you see here is the products that we tested, which is a pig flashlight, a husky flashlight, and a definite flashlight. The ways that we did our tests was the following: a digital sound tester, a light meter, and a force gauge, which you can see on the right. So for the first test was our digital sound level tester. This is the method that was done to find the standard sound level activation of a flashlight. Through this testing, we found that the targeted sound level for a new flashlight design for it to be quieter than standard flashlights. In other words, the amount of decibels shown the meter would be how much sound the flashlight had to create or less. The second test was the light test. The purpose of the light test is to measure how much light each flashlight is generated. This test procedure is similar to the rest, but however, instead of measuring ambient sound, we measured the ambient light and worked in the darkroom. The light from the flashlight was measured in lux. And what lux is a unit of measurement that measures how much light is created when it hits a surface. Through this testing, we could see that different kinds of light was best for a flashlight. The next test that we did was force testing. This test consisted of placing a sturdy flashlight against a piece of wood using a force gauge to measure how many newtons of force were needed on the flashlight to activate it. Through this test, we could determine how much force was needed to activate the best flashlight. In this case, the less force needed to be activated the flashlight is considered the best. The lower the activation force, the easier the flashlight is to use. In the third image is where you can see the type of force gauge that we used to do this testing. We then did functional modeling. And what functional modeling is a method that we used to think of better ways to improve our product. One of the functional models that we used was an exploded view of the pig flashlight. Another one is a predictive sketch, which will be on the next page. The predictive sketch on the next page also includes a C-sketch. The image below is the exploded view, which allows one to quickly be able to find or order a part that is needed for the flashlight. The exploded view also expands and provides more detail for each part, such as shape, size, and even color. The exploded view shows how much the flashlight was assembled and how the relationship between parts works. The information that the exploded view helped us use was to help us get more data so we were able to improve the capabilities of the flashlights. This is the predictive sketch slash C-sketch. So what the predictive sketch was we took the pig flashlight before taking it apart and examining it. We drew a picture of what we thought the flashlight was going to look like on the inside. And for the C-sketch, what we did was we drew our initial flashlight and we passed around our table in groups of 5, and each person drew on the other person next to them's flashlight, expanding the capabilities of what a flashlight could look like. Now, the final thoughts. The Pig flashlight is overall very cheap and affordable for everyone of all ages. This is also good for everyone because it's simple to use and has a very friendly design. Thank you for listening to my flashlight redesign presentation.